So we have a default place in Roblox, and as you can see, nothing new in here. So what you want to do is you want to come to start a player, and you want to go into start a character, script, and you'll add a local script. Okay, this script will be in the player when the player spawns in. So if I go to workspace, I go here, you see local script. This is the script we just made. Right. Okay, now once you've got this in the player, you want to define your local variables. Okay, so what we've done here is we've found the character, because the script will be put in the character, so the parent of the script will be our character. We've got the humanoid root part of the character, which is the main part of a character. We've got our humanoid, which is like just everything in the character, and we've got the user input service. So basically, because we're in a local script, this allows us to detect when the player clicks buttons. So next we're going to write some of the functions to tell us what keys we're like the person's pressing to change the direction of the dash. So if they're holding W, it'll be a forward dash. If they're holding A, it'll be side dash to that side, D the other side. Yeah. Okay, so what we've done now is we've made two functions. The first one is when someone clicks the key, so if they click W, it sets W to true. And then while they're holding W, W will stay true. because the second function, when they release the W key, it then sets W back to false. And we did this for all of the different letters, so we know which one they're holding at the time that they dash. Okay, then we want to make the actual dash function. So right here, this is the keybind for your dash, so you can set this to anything you actually want. It doesn't have to be Q, but I'm using it as Q because I like Q as a dash keybind. Right, so I forgot to add a cooldown to this, so right now there will be no cooldown. So to add a cooldown, what you want to do is you want to do this. Okay. If, so let me do current equals tick if current minus last smaller than 4, so smaller than whatever you want the cooldown to be. Let's put it as 2. Turn and last equals tick. There we go. Print dash. So let's just test this out with the cooldown to see if it worked. We go to output. Let me close all this. Dash, and I'm spam clicking Q. Yeah, the cooldown works. There you go. So now what we have to do is we have to replace the print command with our actual dash code. Okay, right, so what we're doing is we're creating a part at a set direction from the player. So, say I'm here, and where's output gone? Okay, so I forgot to set it to the workspace. Workspace. Okay. Actually, workspace is quicker. There we go. So now it will spawn a tiny cube just to the side of us whenever we click dash, and it will be in the dash direction that we're going. So forwards, backwards, to the side, to the other side. Okay, that's basically all we needed to do for the main function. Now we're going to go on to the individual dash functions. So we have this. So this forward one will be for the forwards dash and the backwards dash, and then the side one will be for the other two, because the side one is like shorter than the other two. Okay. Okay, right, so what we're doing now is we're welding the part to the player so it stays in place. Next, we want to make some new functions to remove the friction of the player. So, we just get these. We can put these in here. They have to be above them so you can call them. So the first one, local function, make breath, frictionless, local properties equals properties.new 000. So it just removes every thing from them, so they have no physical properties at all. And then we do for this in the descendant, so for everything in the character model, if it's a part, then it sets its physical properties to this, and for this one it sets them back to the defaults. Now this might give a few warnings, because I don't think you're completely allowed to set it completely to 0. It needs to be like 0.1, but it still works fine, and if you want to remove the warnings you can. Okay. Okay, so this is a math calculation, and basically what it does is it gets the difference between the parts, so the angle, and then times that by this to create a velocity going straight to the part. So when we place the parts aside, it then creates a velocity which moves us to that part which is at the side, so it dashes us to that side. Now, what I'm going to do is I'm going to change this a bit. Local speed equals 0. So, and then we can replace these numbers with speed. Speed. Okay, so the speed that I found good, the forward dash that I showed in the intro is 70, and yeah. Okay, then what I've got to do is hrp.velocity. So what we're doing here is we're setting the actual velocity of the root part instead of the instead of adding anything in to move it, so that the velocity won't stack up over time, so we'll move at a constant speed, and we'll also be able to have that control where we can go round in a circle, because otherwise it's much harder to get that type of control when dashing. Okay, then oh, I forgot to add a length, so equals do 15. Okay, once we've done this, we can basically just copy this into the side dash part, and then we can just change our values. So the side dash is slightly shorter than the forwards dash, so that's just like half the length, and it's faster, so we can increase the speed. Now that should work. Let's test it. Wait, did I spell velocity wrong? Okay, I spelled velocity wrong, so it's not going to work. I accidentally added an extra O. That should be that there. Instead, yeah, and I did it up here. Okay, so if we play test now, it should find, yeah, so you see, we got that, and you can turn very well. But right now, it looks a bit weird because we don't have any animations for our dash, so it just makes us look like we're walking faster. Now this works pretty well because with most dashes that have movement, you fall as well, so gravity applies, so you won't just start flying. Yeah. Now what we want to do is we want to make the animation so it looks smoother, because right now it doesn't look very good. And we also can set the part transparency to 1 because we know it's working. Right, to make an animation, you want to head over to the avatar at the top. You want to do rig builder. Our game is R15 right now. It doesn't really matter. Pick the one that your game is, because this works on R15 and R6. We're R15, so we do that. Let's just make a block avatar. Okay, so this is our block avatar. Then we want to click animation editor. We click on here. Let me just bring this up here. untitled animation clip, we can call this left dash create. So to the left. So we want it to move. He's going to be moving this way. So I'm not very good at making animations, by the way. So you might just want to not follow anything that I do in this step. It might not work. Okay, now what we want to do now is, once we've done all that, we want to go to our local script that we made. We can call this dash now. Then we want to add animation. And we want to add 4 animations. So name W A D and S. Okay, so we just made our A animation. So we can put the animation ID there for A. And if we go into our dash, this is why we needed the humanoid. Local anim A equals hum load load animation, and then script.a. So that'll be our animation for this, and then if we have A, we can do anim A. And then if we go to our side at the end, anim A, we can stop it. So if we do our play, it worked a bit better that time, but not much. You can see it tilts to the side, but we still run a bit. Look, I'm not good at making animations, but the dash movement works, so if you can make your own animation for it, it'll be fine. And anything you want to change, speed, length, those will basically be the only things that matter when you change them. Yeah, I think I should have explained all of it. So, okay, so what it does completely, finds the character, finds the humanoid root part of the character, which if we go to our dummy in the workspace, we go to him, if you find this square here, it's a hidden part, it's because it's transparency 1. If we find it, basically in every humanoid character, there's this brick part in the center of their torso, and this can have loads of different it's basically just a normal part, but the character uses it as the main middle part. So basically this will always be in the middle of the character, even when playing an animation. So that's how we place the cube, because if we use the torso and we were mid animation, it would place a cube up here or something and in the wrong place. So we always want to use the humanoid root part. So once we've done that, it stays there. Then we get the humanoid, which is this thing here, which basically controls all the statistics of the humanoid, like its warp speed, its jump height, its health, and all of that. And it also allows us to play animations. So then we do our animation equals hum.load animation, and then the actual where the animation is, which will be in our script here. And then we get our user input service, which is a thing that allows us to detect when the player clicks buttons. We set variables for each of the buttons for the different dash directions. We get this is for our cooldown. Now, because our cooldown, we know it's 2 seconds, we can actually just do last equals -2 here. So what that does is, instead of having the delay when you spawn, you can instantly dash off spawn. Yeah, so that works a bit better. And this will be our cooldown. This won't affect it otherwise, because other than the first dash. Okay. Then we have our 2 things here, which are big blocks. all they do is change these variables to true or false depending on when you click and let go of clicking the movement keys. So if you click W, sets it to true. If you let go of W, it sets it to false. This sets the player to 0 friction, so it will slide more, because otherwise if you jumped and dashed, you would move further than if you just dashed. So we don't want that, so we set the friction to 0 so they move the same distance in the air and on the ground. Then we have our forward function and our sideways function. You don't have to have two separate functions, it's just I like it so I can change the length of these. So if let me just increase these both in length. So now my forward dash will be longer, yeah, like that, and my side dash will be shorter. Yeah. That is the point. We also, side dashes are supposed to be like a bit faster than forward dashes, because this is based off the strongest battlegrounds. Yeah, so that's a difference. Back dashes and forward dashes are more slow and they're kind of similar, so yeah. Then this is our main function. This also detects when we click, but this only cares if we click Q, and then it will stop if we're not clicking any movement keys. So if I just click Q, here nothing happens because I'm not clicking any of the movement keys. So if I click A, then it works. Okay, then this is our cooldown. So what we do here is tick just gets what in-game tick we're on, so like the time that's happened, and then if the time now is 2 seconds larger, is more than 2 seconds larger than the last time we did the move, then it will run. If it's smaller than 2, then it will not run. Basically, return just ends it. So if you see a return, that will end the function, and then it will wait till it's rerun again. Then we make a part. This is the part that controls like the direction of our dash. We set the part size to 1. You don't have to do this, but it doesn't really matter. We unanchor it. We have to do this, otherwise the dash won't work at all. Transparency to 1. Otherwise you'll just see loads of parts on your screen when dashing. You won't see other people's parts because it is a local script, but you will see your own. We said it can collide false. That's needed because otherwise you can just hit a wall and it can bug out. Massless, we also need that because if it's not massless, it can like stop us from like turning our character well enough. Then we set it to the workspace. We need that because otherwise the part literally just doesn't exist. Then we set the C frame, which basically is just like the orientation and the position of the part. So we orientate it to our humanoid root part and the position of our humanoid root part plus this. So we -5 is so if you have a minus number in the last column, it goes forwards. If you and then the number is the distance in studs. If you have it in this column, it will be minus will be to the left, positive will be to the right, and the number is also the number of studs. So you can see A is left, D is right, and then we have no minus on the back because minus is forwards, not minus is backwards, which is a bit confusing, but it's not too hard to work with. Okay, that should be it for the dash. If you want to see right, so I do have a game where I made this dash and I actually have animations for it, because this is an R6, so it does work for R6, but the point of this is that we can, like, it's a bit smoother, and it's easier to make animations in R6, personally, probably because I'm not very good at making animations, but yeah, it looks a lot smoother with these animations than it did, but this is the exact same code. Okay, thank you for watching.